Fusion Mobile, quality e-learning experience on the go.
My name is Bolaji. I'm here to speak on the subject mathematics, and our topic before us today is linear inequality 2. Linear inequality 2. In our first topic, in our linear inequality, we consider the use of number lines. We consider solutions that involve one variables. We consider solutions that involve two variables. But now, we want to be using graphical method to solve inequality that involve two variables. We want to see maximum and minimum values of linear inequality. We want to see what problem leading to inequalities. These are the three things we are going to consider in this topic, linear inequality 2. Now, what do I mean by graphical? Graphical solutions. So we are going to make use of our graph. I would like you to use our y-external graph and open to the graph. Now, let us consider this example. Solve the inequality and show the graph of relationship. Graphical method. Solution of linear inequality. Graphical solution of linear inequality. Now, I say solve the inequalities. Solve the inequalities of this solution and show the graph of the relationship. And show the graph of the relationship. Now, this question is two things, that is x plus 2y is greater than or equal to 3x minus 4. X plus 2y is greater than or equal to 3x minus 4. Solve the inequality and show the graph of the relationship. If it's two things, we have to first solve the inequality. Now, it involves two variables. X and y is our variable in this aspect. How do we solve this? Now, solution. Solution to this question. We said x plus 2y is less than or equal to 3x minus 4. What we do is that we discover that we have x here, we have x here. The first thing is that you collect like term. Now, the term that is common, we have 3x. Collect like terms, that is 2y is less than or equal to 3x minus x minus 4. Therefore, 2y is less than or equal to 3x minus x will give us 2x minus 4. Now, this is our right hand side, this is our left hand side. We discovered that 2 can divide here. 2 can also divide our right hand side. The next step is divide both sides by 2. 2y over 2, then 2x over 2 minus 4 over 2. 2 here 1, 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 2 here 2. We have y is less than or equal to x minus 2. Now, we've solved this inequality to be this. The next thing that we're going to do is that we're going to use graphical method. This is the first stage of the question. We are correct here. Now we have to look for the graphical method. I want you to open to your graph, open to a y-external graph, then open to your graph. You will say that in your graph we have the y-axis, we have the x-axis. Divide your graph into different columns. We have column which represent the y-axis. We have horizontal axis which represent the x-axis. Therefore, we name this place to be y-axis. This place is minus y. This place is minus x. This place is x-axis. Now, you start from 0 here. Now, this is where we resolve our answer into. Then, we now make it to be y is less than or equal to x minus 2. Using graphical method, we are going to use y is equal to x minus 2. What is our y when x is equal to 0? What is our y when x is equal to 0? Now write y is equal to, when x is equal to 0, y is equal to 0 minus 2, y is equal to minus 2. So y is equal to minus 2 when x is equal to 0. But when y is equal to 0, what is our x? When y is equal to 0, then x is question mark. When y is equal to 0, what is our x? Y equal to x minus 2, then y equal to 0, we have x minus 2. Therefore, if we have 0 equal to x minus 2, now the x will come, cross the equality sign and turn to minus x equal to what? Minus 2. Now, we can't have minus x equal to minus 2. What we do is that to remove this minus sign, multiply both sides by minus 1. Minus 1 times minus x is equal to minus 2 times minus 1. Minus times minus will give us what? Plus. We have x equal to minus 2 times minus 1 will give us 2. So therefore, when y is equal to 0, our x is equal to what? 2. So this has justified our answer. Our x is equal to 2 when y equal to 0. Wow. Now on your graph, I would like you to see what we've gotten. Now choose your scale on your graph. Remember, when we're dealing with quadratic equations, we know how we chose our scales. Now let us now choose our scale here. You can set 2 centimeter to represent 2 centimeter to represent 1 unit on y-axis, and 2 centimeter to represent 1 unit on the x-axis. On the x-axis. That is 2 centimeter to represent 1 unit on the y-axis, and 2 centimeter to represent 1 unit on the x-axis. Therefore, let's start. Use your ruler, measure 2 centimeter. This is 1. This is 2. This is 3. This is 4. Now this is 1. That is minus 1 in this region, minus 2, minus 3, then minus 4. Here we have minus 1, minus 2, minus 3, minus 4. Here we have 1, 2, 3, and 4. So now, let's check when x is equal to 0, what is our y? Our y was minus 2, so you asterisk this side on your graph. I'd like you to look at what I'm showing you on the board. As I'm marking it on the board, be marking it in your graph. Now when x is equal, when y equal to 0, what is our x? Our x is equal to what? 2. So you asterisk it like this. Now we have to join our asterisks together. You discover that we have minus 2 and 2. So we have this graph like this. When x is equal to 0, our y was minus 2. When y is equal to 0, our x was 2. So we connect this point together, we join it with our pencil. Join 2 on the x-axis with minus 2 on the y-axis. This is what we have gotten from our graph. I would like us to consider few evaluations on this graphical method to solve linear inequality that involve two variables. I am delighted because you've gotten the answer correctly. But if you still have a shady mind over this topic, I would like you to go back and rewind so that you can get the topic rightly and you can get your answer accurately. Now, let us move forward by considering what is called maximum and minimum point of a linear inequality. Maximum and minimum point of a linear inequality. Now, maximum and minimum points of a linear inequalities. Now, we consider maximum and minimum point in quadratic equations when we're using graphical solution to solve quadratic equations. But here we are in linear inequalities. We want to use maximum point and minimum point to dictate variables on our graph. Let us consider this question. Show the region, example 1, show the region satisfying the set of inequality. Show the region that satisfy the linear inequalities. The linear inequality shows the region that satisfies the linear inequality y plus x is less than or equal to 3. Y plus x is less than or equal to 3, comma, y plus x is greater than or equal to 1. Y plus x is greater than or equal to 1. And the last one, y minus x is less than or equal to 1. Y minus x is less than or equal to 1. There is condition. They put us that x is greater than or equal to 0. X is greater than or equal to 0, comma, x is greater than or equal to 0, and y is greater than or equal to 0. Now, this is questions that we are about to solve. That is, show the region that satisfies the linear inequalities. Y plus x is less than or equal to 3. Y plus x is greater than or equal to 1. Y minus x is less than or equal to 1 for a condition that x is greater than or equal to 0, y is greater than or equal to 0. Now, solution. The solution to this question is this. Y plus x is equal to 0, is equal to 3. What is our y? When x is equal to 0, what is our y? Y plus 0 equal to 3. Y equal to 3. So when x equal to 0, y was equal to 3. Now, when y is equal to 0, what is our x? When y is equal to 0, what is our x? Is 0 plus x equal to 3. Therefore, x was equal to 3. Our x was equal to 3 when y equal to 0. The first thing is that when x was equal to 0, our y was equal to 3. And when y equal to 0 also, our x was equal to 3. That's for this question. For this equation, y plus x is greater than 1. We have y plus x is equal to 1. So what is our value of x when y equal to 0? When y equal to 0 plus x, our x is equal to 1. Y equal to 0, x is equal to 1. Then, when x is equal to 0, what is our y? When x is equal to 0, what is our y? When x equal to 0, y plus 0 equal to 1. Y equal to 1. Our y was equal to 1. Now, the third question stated that y minus x is equal to 1. When y equal to 0, when y equal to 0, what is our x? We have minus x equal to 1. We have minus x is equal to 1. Multiply both sides by minus 1. Minus 1 times minus x equal to 1 times minus 1. We now have x is equal to minus 1. So when y was equal to 0, our x was minus 1. Our x was equal to minus 1. When x is not equal to 0, y equal to x equal to 0, what is our y? Our y is equal to what? 1. Our y was equal to 1. When y was equal to 0, what is our x? Minus 1. Then, when x is equal to 0, what is our y? Our y was 1. Now, we are going to show this on the graph so as to see how we can interpret this question effectively. I would like you to use your graph, open to your graph, then how we solve the first equation earlier on, and that's what we are going to do. I'd like you to open to your graph. Now, in your graph, I've told you that you divide it into two equal parts. Now, this is our x-axis. This is our y-axis. This is our minus y. This is our minus x. Now, the next thing is that you choose your scale. Now, I've told you that let's use 2 centimeters to represent 1 unit on y-axis and 2 centimeters to represent 1 unit on x-axis. Therefore, this place is 1, 2, 3, 4. This place is minus 1, minus 2, minus 3, minus 4. And this place is minus 1, minus 2, minus 3, minus 4. This place is 1, 2, 3, 4. 1, 2, 3, 4. Now, we said that 2 centimeters to represent 1 unit, you place your ruler, 2 centimeters, 1, 2, the same thing applicable to both x-axis and y-axis. Now, we have to start by making sure that at point A, at point B, at point C, at point D, because these two graphs, the graph we're about to plot on this graph now, will show us the linear relationship between the inequality equations that we solve. Now, I'd like you to trace to this. When y was equal to, y minus x was equal to 1, what is our x? What is our y? You discover that our x was what? When we solved the question earlier on. Now, when y minus x was equal to 1, y minus x equal to 1. What is the value of our x? We say when y was equal to 0, we have minus x equal to 1. Our x was equal to minus 1. So now you have to trace here. When y was equal to 0, what is our x? What is our x? Our x was minus 1. You trace your minus 1 here. Then here, when x was equal to 0, what is our x? What is our y? y minus 0 equal to 1. Y equal to what? 1. So we trace our 1 here. That's the value. Now we've succeeded by having this value for y minus x equal to 1. Now let us move to another one from the equation that stated that y plus x is equal to 3. Y plus x is equal to 3. What is our y when x is equal to 0? Y plus 0 equal to 3. Y equal to 3. Now, when x equal to 0, what is y? Y is equal to 3. We trace our y like this. When x is equal to 0, what is our y? Y, okay, what is our x? When y equal to 0, 0 plus x equal to 3. X is equal to 3. So we mark our x here. So you draw the graph like this. You draw the graph like this. Now, the graph of y minus x equal to 1. This is the graph of y plus x equal to 3. We are not yet through because we are still going to plot another graph. Now, when y plus x is equal to 1, what is the value of our x and y? When y is equal to 0 plus x equal to 1, our x is equal to 1. Then we trace our x equal to 1 here. Good. Then, what is the value of x, of y, when x is equal to 0? Y plus 0 equal to 1, y equal to 1. Then our y was equal to 1, and our x was equal to 1. So we trace from your graph. I'd like you to join all the asterisk. So we trace this graph like this. Trace your x here. You trace your x here. Wow. This is the graph we are going to find. Now, I would like you to see how the graph is being plotted. Now, look at this point here. You discover that we have different points. A, 1, 2, 3, 4. 4 points are being shown in this graph here. Now, y minus x is equal to 1 was this. Then, y plus x equal to 3 was this. Correct. Then, y plus x equal to 1 was this. Y plus x equal to 1 was this graph. Now, I want us to put marks on this thing so that you see what we are saying. Now, look at the graph very well. You discover that we have points that join here, that join this place. Now, we have the different graph have been shown here. Y minus x equal to 1. Look at your graph very well. Y plus x equal to 1. Y minus x equal to 1. Y plus x equal to 3. This is the way your graph will look like. But on this graph, there are points. And this point is, the point here is showing us that this is the D point. And this is the C point. The other points are, this is the A point, and this is the B point. Now, look at your graph very well. You discover that we have 4 points on your graph. Thereafter, we've shown different regions of this inequality on each graph. We're showing different regions of inequality on this graph. That is, here in B part, when our B is equal to 3, we have 0 here. Then in this part, we have C equal to, you trace it down here, you discover that we have 2. Then if you trace here, we have 1. Absolutely correct. On my point is correct. We have what? C equal to 1, 2. Then also, in the D part, we have 0, 1. So this is the point of the region on this graph. On the A part that is here, I'd like you to look at the A part. We have A bracket into 0, 1. So this is the region that satisfies the equation. In your graph, in my board here, it shows absolutely correct. Check your graph, it is correct because the C point, the intersection of y minus x equal to 1, and the intersection of this point here has clarified that we are correct. On the intersection on the x-axis is 2, on the intersection on the y-axis is 1. So the C point at the point of intersection of this y plus x equal to 3 and y minus x equal to 1 lies at the same point on your graph. Lies at the same point on your graph. Thank you. I'm so much delighted because you understood this topic. I would like us to solve few evaluations so as to confirm how far we have gone in this topic. You're welcome. Once again, I'm happy because you've understood these questions that we solved. Now, I want us to proceed by showing the maximum and minimum point on the same graph we've plotted. Open to that graph again. Look at point A. Point A on the graph, we have 1, 0. Point B, we have 3, 0. Point C, we have 1, 2, with that intersection that I show you. Then at point D, we have 0, 1. Now, the question is that we want to find the maximum and the minimum point. The maximum and the minimum point on that graph we've drawn. Now, let's consider these questions. Find the minimum and maximum value of the graph we've drawn with a functions. Find, example 1, find the minimum and maximum point on the graph in question above. Find the minimum and the maximum point on the graph in the question above. Look at your graph. You discover that at point A we have 1.0, at point B we have 3, 0, at point C we have 1, 2, at point D we have 0, 1. Check your graph very well. Now we want to find the minimum and the maximum point. If you have a function of function, x, that is f function x, function y, function x, y, giving us an equation that is equal to 3x plus 4y, 3x plus 4y. With these functions and with this point on the graph that we've drawn, they say we should find the minimum and maximum point. Very simple. This is our x and this is our y for point A. This is our x and this is our y for point B. This is our x, this is our y for point C. This is our y, this is our x for point D. This is a function of the equations. This is two variables, x and y. F function, x, y, from the graph that we have drawn. It's very simple. Check your graph very well. Therefore, substitute solution to it. At point A, we have 1, 0 at A. Then what is our x value? What is our y value? Now, at A, when x is equal to 1, what is the value of y? When x equal to 1, what is the value of y? That is the question we are about to solve now. And then when x is equal to 1 and x equal to 0, we substitute the value. Now, this is our x. Therefore, x is equal to 1 and then y equal to 0. That is the implication of this question for point A. Therefore, we now have f function x comma y, which has been shown here, 3x, which is equal to 3x plus 4y. We have f function x comma y is equal to 3 bracket into, what is our x? 1 plus 4 times y. 4 times y, which is what? 0. We now have f bracket x, f function xy is equal to 3 times 1, we have 3 plus 0. f function x comma y is equal to 3. At point A, we have f function xy equal to 3 at point A. What is f function xy at point B? F function xy at point B, that is what we are going to show down. Now, at point B, we have 3, 0. Then we have f function xy equal to 3x plus 4y. We substitute our value of x and y, which is equal to 3 bracket into 3 plus 4 bracket to 0, which you have 3 times 3 will give us 9 plus 0. We have 9. So at point B, we have 9. At point B, we have 9. Then at point C, what is our value at point C? At point C, what is our value? Our value for f function xy equal to 3x plus 4y, which is equal to 3 bracket 1 plus 4 bracket into 2. We have 3 plus 8, which will now give us what? 11. At point C, we have 11. At point C, we have 11. At point D, where we have, what is the point at point D? Remember at point D that our x was 0 and our y was 1. Our x was 0, 0,1, and our y was 1. Therefore, we now have f function x comma y is equal to 3x plus 4y, which will give us 3 bracket into 0 plus 4 times 1, which will now give us 0 plus 4, and we have 4. So at point D, at point A, we have 3. At point D, we have 9. At point C, we have 11. Remember? At point C, at point D, we have 4. Now, once we've gotten this answer, remember you have to put your C, 11, your D, 4, our A equal to 3, our B is equal to 9. So, we want to now know the maximum point and the minimum point. The maximum point from the value we've gotten at each point on that graph that we have drawn. I'd like you to check your graph once again. At each point, there is value of x and y. So now, at point A, we have 3. At point B, we have 9. At point C, we have 11. At point D, we have 4. Now, on this graph, you now discover that at point C, the maximum value is what? 11. At point A, the minimum value is what? 3. So at that point is what we are going to say and write C, 1, 2 is the maximum point. Is the maximum point? Is the maximum point on the graph? Is the maximum point on the graph of f bracket f function y equal to 3x plus 4y is the maximum point. Why the minimum point? Our minimum point is A, at point A, bracket into what? 1, 0, 1, 0, which give us 3. This is the minimum point on f function x, y equal to 3x plus 4y. equal to 3x plus 4y. So this has shown the minimum point and the maximum point pertaining to linear inequality. I am so much confident that you understood this topic, linear inequality, using graphical solutions and finding our maximum and minimum point on the graph. I would like us to solve few evaluations so that we can know how far we have gone in this topic. Yes, I'm confident that you've understood this question perfectly well. Let's continue by considering what problems in linear inequalities. What problem in linear inequalities? There are some word sentences that can lead to inequality equations. Let's take, for example, I think of a number. I think of a number had 24 to it, and the result is greater than 42. I think of a number and had 24 to it, and the result is greater than 42. What is the number? How do I solve this question? First thing, we write solution. Solution. I think of a number. Solution. Let the number be x. Let the number be x. And add, the word add here is plus. X plus 24, and the result is greater than 42. Greater than 42. Now you can see that I have shown how this equation look like. I think of a number and had 24, and the result is greater than 42. What is the number? What is the number? So now, it is the number I want to find, value of x. And now say solution, let the number be x. X plus 24 is greater than 42. Therefore, what do I do? Remember, in our inequality 1, we said had the additive inverse of 24 to both sides. Remember, this is our right hand side, this is our left hand side. X plus 24 minus 24. The additive inverse of plus 24 is minus 24, is greater than 42 minus 24. Then x plus 24 minus 24 will give us 0. This will cancel each other. X is greater than 42 minus 24. 42, 24. We have 12 here. 8. We have 3 here. 1. X is greater than 18. X is greater than 18. So now, the number is that this x is greater than 18. It means that our x is equal to 18. Our x is equal to 18. Now, that is the number that I think of. Now, look at the question now. 18 plus 24. 18 plus 24 will give us 42. Will give us 42. Absolutely correct. So the number that I think of, and I had it with 24, and the result was 42, is 18. Is 18. Now, I will conclude in this topic by saying that we should do this few evaluation to really know how far we have gone in this topic, because we've considered the use of graphical method to solve linear inequality that involve two variables. We've used the method of graphical method to solve an inequality and determine its maximum and minimum point. Now, it is word problems. that we use to unravel linear inequality. I would like you to solve these evaluations accurately and think over it so that you can get your absolutely answers. Thank you.